Hi, my name is Kishan and today we are going to learn about reverse shell. So what is reverse shell? Reverse shell is a shell session established on a connection that is initiated from a remote machine and not from a local host. So we do this at reverse shell to, let's say, we are going to connect to our friend's laptop or something to help them remotely control their laptop help them fix some problem. So this is what we call reverse shell. So before we learn this, let me explain to you some key terms that we need to know about our daily computers. The first thing that we need to know is IP address. What is IP address? IP address is a unique address that identifies a device on the internet or a local network. IP stands for Internet Protocol, which is the set of rules governing the format of data sent via the internet or local network. So IP address is basically a series of numbers separated by full stops that identify each device in that network, either in the internet or local area network. Next is ports. So what is a port? A port is the number in the IP address that basically is determines the path that the files or data sent to the device goes to. So let's say in a certain device, some data needs to go to the Netflix app and the other data needs to go to the WhatsApp app. So the port determines, but the port is basically the address that the server uses to know which app it should send each individual data to. Next, about IP addresses, I would like to state that there is also such a thing called static and dynamic IP addresses. So what's the difference between a dynamic and static IP address? Well, when a device is assigned a static IP address, the address does not change. It remains the same forever. This is normally this is normally true for certain things such as servers and big websites such as Google and Facebook. For them all, they only use a static IP address. However, for devices that we use at home, such as our laptops and phones, they have dynamic IP addresses, which means they constantly change. So that's why most devices use a dynamic IP address, which are assigned by the network, which is by our router, to connect and change over time. Let's say we restart the device or we reconnect to the internet by disconnecting and reconnecting again. So now I'm gonna tell you one more thing, which is sockets. So what is a socket? Well, a socket is one endpoint of a two-way communication link between two programs running on the network. A socket is bound to a port number so that the TCP layer can identify the application that data is destined to be sent to. An endpoint is a combination of an IP address and a port number. A socket is basically the connection between a friend and your laptop, which is one way. So now let's start with our reverse shell project here. So basically, what we are going to do here is we are setting up a server that we are going to use to help another device, such as, let's say, a friend, to remotely connect to their laptop and so we can communicate with that laptop and communicate with them and control their laptop. So here we have put here import socket and import sys, which is something which is this one we established by ourselves. So now we are going to create a socket, the connection of the two computers. So we're going to define create socket. This is our definition, and we're going to call three global uh, definitions, which is host, port, and S. S is for socket, but I'm just going to write here S here. And our port here is going to be 9999. 9999 is used because it is not going to be taken up by system, such as 80 is for HTTP and 40 is for FLP. So we don't want any of those. We want an empty one, so we're going to use 9999. So as here is going to be socket.socket. That's what I said earlier. So when our system runs, okay, our system is going to be defined by has three definitions. So create socket, bind socket, and socket accept. So it's going to run through each one of them. So the first one is going to be creating a socket. So as I said here, we're going to call 3 global. This global means we can use it anywhere else, not just in this definition. You can use it in the whole system. So let's say when when our server is going to create a socket, okay, let's say this is running and it fails to do so, it will start executing the except. So socket error except. So when this error occurs, it will print out socket creation error is occurring, and with the message from the string to inform us what error it is. So after it has completed the create socket, we're going to bind the socket. So this is the binding the socket, so that we can listen to a connection from the client. So now we're going to call in our global definitions here, host, port, and S, and we're going to print out binding the port. So this way we can know that the system is currently trying to bind the port. And this port is the number we're going to say 9999. And S bind is basically the socket bind. And S listen is something where the server is trying to listen for a connection. So it will try to listen. The 5 here is basically the server trying to listen for a connection, and it will try to set up a connection with at least 5 times. And if it does not have set up a connection by then, it will start executing the accept socket error, where it will print out socket binding error with the string message of what type of error it is, and then it will also retry it. So we want it to retry, so that if possible, we want to create a connection. So we wanted to retry it again. So after it prints out socket error, binding error, and what error it is, it will actually retry again by executing this bind socket function again. After the connection is after the socket has gotten a connection, it will start accepting the connection. We can't only just listen for a connection, we have to accept and connect and actually establish a connection. So our next command will be socket accept. So this is for establishing a connection with the client. So we are going to write here con comma address equals to s.accept. So socket accept. So this will print out connection has been established with the IP address and the port and string address. So the send command is basically our function to send commands here later on. And after we have accepted the socket, here after that we can actually send commands to our client by communicating. So basically, when we are sending commands, we want to run this function infinitely, because every time we send a command, we don't want it to end. We don't want it to end the connection. We want to send and keep receiving and sending information or data, so infinitely until we want to actually end it. So what we're going to do is going to do a while loop here. So this way, it won't actually end the connection until we end it. So we're going to write here while true. So as long as we are still sending and we want to continue, it will still, this basically means an infinite loop. So until we actually type in end, it will not end. So here we're going to enter our inputs, and if our command is actually quit, then only it will end our connection. And when it ends our connection, the connection will close, the socket will close, and the command prompt, the interface we are going to talk to them through, is going to close to exit. And if we don't quit, we can actually send messages, as I said here. By how we're going to send is, it will send through the internet, and it will send it by bits, right? So we have to convert our string into bits. So this is to convert our strings into bit. Here the len bracket str.encode command bracket more than 0. This line means that whenever we hit the enter button without typing anything, it won't send anything. So this line, it actually means it will only execute this function when we actually type something which is more than 0. If we don't type, it's going to be equal 0, so it won't execute this function. So we have to type something for it to send something. So after this, so if we, let's say we type hi or anything, which is more than 0, true, so it will start connect send, and it will convert our string into bits, and it will send it to our client. And after that, it's the client response is the string, we will respond, and the print, it will print the client response. Whenever the client is responding, it will print it to us, and end. So this is so much what we have learned, and we have learned today. See you next time. Thank you.